Hello Year 9, welcome to this problem solving question. I think it was question 10 from our problem solving books. So the problem states, if a plus b plus c is greater than or equal to abc, prove that a squared plus b squared plus c squared must also be greater than or equal to abc, where a, b and c are positive. So I've broken this into two cases. My first case, I've said, let's just say A, B and C are all greater than or equal to 1. So if A, B and C are all greater than or equal to 1, A squared is greater than or equal to A, B squared is greater than or equal to B, and C squared is greater than or equal to C, because if I square any number bigger than 1, it obviously gets bigger. So if I add all of these together, A squared plus B squared plus C squared, it must be bigger than A plus B plus C, because each of the terms on the left is bigger than each of the terms on the right. But because I know from my assumption A plus B plus C is greater than or equal to ABC, then if A, B and C are greater than or equal to 1, then A squared plus B squared plus C squared must also be bigger than ABC, because A plus B plus C is bigger than ABC, and A squared plus B squared plus C squared is bigger than A plus B plus C. It gets a bit trickier if all these numbers aren't necessarily bigger than 1. So before we start K2, I just want to draw your attention to this little proof I've got here. If I have a minus b all squared, that's greater than or equal to 0, because anything squared is greater than or equal to 0. So I expand out the left-hand side, and then I move the 2ab over to here, and I get a squared plus b squared is greater than or equal to 2ab from here. This is an identity you'll see quite a bit when we do proofs in equations and things. Alright, so now we've seen this, let's move on to case 2. So say that let's just say one of these terms is less than 1, and I'll say C is less than 1, but it could be A or it could be B, doesn't really matter, they're all the same. So if C is less than 1, ABC is less than AB, because C is less than 1, so when I multiply AB by C, I'm reducing it because I'm timesing by a number less than 1. But I also know AB is less than 2AB, because if I double something it gets bigger, provided that A and B are both positive, of course. But 2AB is less than or equal to A squared plus B squared, and I know that from my little identity we made up here. But I know A squared plus B squared is less than A squared plus B squared plus C squared, because I'm adding C squared onto this side and C squared's positive, so it must increase by a little bit. So I've got ABC is the smallest, AB has to be bigger, but 2AB is bigger than AB. A squared plus B squared is bigger than 2AB, and A squared plus B squared plus C squared is bigger than A squared plus B squared. So I've written out all of these terms are here in ascending order, the smallest going up here, up until I get to the largest. So if A squared plus B squared plus C squared is the largest of these terms, and ABC is the smallest, then A squared plus B squared plus C squared must be bigger than ABC, and we're done.